Imagine an aircraft so massive it can swallow two M1 Abrams tanks whole, fly them halfway around the world, and land on a runway shorter than most commercial airports use. An aircraft with a cargo bay longer than the Wright brothers' first flight. A flying warehouse that has been the backbone of America's strategic airlift for over half a century. Meet the Lockheed C-5 Galaxy, the aircraft that redefined what heavy lift means in military aviation. For 55 years, this giant has been quietly reshaping global power projection, delivering hope to disaster zones, and proving that in aerospace engineering, bigger isn't just better, it's sometimes the only option. Welcome back to Project Aerospace. Today we're diving deep into one of aviation's most impressive success stories, the C-5 Galaxy. From its controversial development in the 1960s to its current modernized Super Galaxy variant, this aircraft has been bigger, heavier, and more capable than anything else flying. This isn't just about an oversized cargo plane. We're talking about the aircraft that airlifted supplies to save Israel in 1973, delivered relief to Rwanda in 1994, supported every major American military operation for 5 decades, and continues serving as the largest aircraft in the U.S. Air Force inventory today. If you're here for deep technical analysis and the untold stories behind legendary aircraft, hit that subscribe button and notification bell. Today's deep dive covers the engineering marvel that is the C-5, the operational history that made it legendary, and why this 55-year-old design remains absolutely irreplaceable in 2025. Our story begins in the mid-1960s, during the height of the Cold War. The U.S. Air Force faced a critical strategic problem. Their largest cargo aircraft, the C-141 Starlifter, simply wasn't big enough for America's global military commitments. The military needed something revolutionary as an aircraft that could carry outsized cargo like helicopters, tanks, and missiles without disassembly. They needed intercontinental range without aerial refueling, and they needed it to operate from the same runways as the C-141, despite being vastly larger. In 1964, the Air Force launched the CX Heavy Logistics System Competition, demanding capabilities that seemed impossible. Carrying 125,000 pounds of cargo for 8,000 miles or 220,000 pounds for 3,000 miles. Operate from 4,000-foot runways, load and unload simultaneously from both ends. Lockheed won the competition with an audacious design, an aircraft with a wingspan of 222 feet, length of 247 feet, and a cargo bay 121 feet long. To put that in perspective, you could park a 737 airliner inside the C-5's cargo hold with room to spare. The first C-5A Galaxy rolled out of Lockheed's Marietta, Georgia plant on March 2, 1968. On June 30, 1968, test pilot Leo Sullivan lifted his behemoth into the sky for the first time using the radio call sign 8303 Heavy, a designation that would become synonymous with American strategic airlift. But the program faced immediate challenges. Cost overruns ballooned to unprecedented levels. The C-5A became one of the most expensive aircraft programs in history. Technical problems plagued early operations. Wing cracks grounded the fleet multiple times. Critics called it a white elephant, a disaster, a plane that would bankrupt the manufacturer. They were all wrong. The C-5 would prove itself in ways nobody imagined. To understand why the C-5 remains irreplaceable, we need to examine the engineering brilliance that makes this giant fly. This isn't just a scaled-up cargo plane. It's a masterpiece of aerospace engineering that pushed technology to its absolute limits. Let's start with the dimensions that define the Galaxy. The aircraft measures 75.53 meters in length with a wingspan of 67.91 meters and stands 19.84 meters tall. The cargo bay alone is 36.91 meters long, 5.79 meters wide, and 4.09 meters high, essentially a tunnel large enough to drive trucks through. The maximum takeoff weight reaches 381,018 kilograms, that's over 840,000 pounds. Empty, the aircraft weighs 181,437 kilograms, meaning the C-5 can carry its own weight in cargo and fuel. The wing design is particularly brilliant. High-mounted swept wings with 25 degrees of sweep generate enormous lift while minimizing interference with the massive fuselage. The wing incorporates full-span leading-edge slats and trailing-edge flaps that dramatically increase lift at low speeds. Here's what makes this remarkable. Despite weighing over 800,000 pounds at takeoff, the C-5 can become airborne in just 8,300 feet and land in 4,900 feet. These are shorter distances than many aircraft one-tenth of Galaxy's size require. The landing gear system is equally impressive. 28 wheels distributed across 4 main landing gear trucks and 2 nose gear assemblies spread the aircraft's weight to allow operations on semi-prepared runways. The gear can kneel to lower the cargo floor to truck bed height for direct loading. But the true genius is in the cargo handling system. Both the nose and the tail of the aircraft feature full-width, full-height cargo doors. Combined with an integrated load system of rollers and winches, the C-5 can simultaneously load from the front while offloading from the rear. The drive-through capability means the C-5 can completely load and offload under 30 minutes, critical when operating in hostile environments where time on the ground equals vulnerability. By the 2000s, the C-5 fleet faced a critical decision point. The aircraft were aging, maintenance costs were climbing, and reliability was declining. The Air Force had 3 options: retire the fleet, replace it entirely, or modernize it comprehensively. They chose the third option, launching the C-5M Super Galaxy Modernization Program, one of the most extensive aircraft upgrade programs in aviation history. This wasn't just maintenance, it was essentially building new aircraft around existing airframes. The centerpiece of the modernization was complete engine replacement. Out went the original Pratt & Whitney TF-39 engines, replaced by General Electric CF6 80C2 turbofans, military designation F-138-GE-100, each producing 225 kilonewtons. That's 50,580 pounds of thrust per engine. The new engines transformed the aircraft's performance. Thrust increased by 22%, improving takeoff performance, climb rate, and cruise altitude capability. More importantly, fuel efficiency improved dramatically, extending range and reducing operating costs. The Super Galaxy can now carry 20% more payload than legacy C-5s, while achieving departure reliability rates greater than 90%, a remarkable achievement for an aircraft this complex. With substantial improvements in unrefueled range, the C-5M now overflies traditional en route fuel stops, reducing mission time and complexity. But the engines were just the beginning. The C-5M received a complete glass cockpit with modern avionics, replacing analog instruments with digital displays. New communication systems, navigation equipment, and automated flight controls brought the Galaxy into the 21st century. The modernization integrated over 70 enhancements and significantly reduced maintenance requirements per flight hour. What once required a crew of 6 now operates efficiently with a crew of 3 or 4, thanks to automation and improved systems reliability. The C-5's operational history reads like a chronicle of modern American military and humanitarian operations. For over 5 decades, when the world needed massive amounts of cargo delivered urgently to remote locations, the Galaxy answered the call. Let's start with Operation Nickel Grass in October 1973, the mission that made the C-5 legendary. When Israel faced existential threat during the Yom Kippur War, President Nixon ordered a massive airlift of military equipment. C-5 Galaxies flew non-stop missions from the United States to Israel, delivering tanks, artillery, ammunition, and supplies. When the first C-5 arrived with critically needed supplies, Israeli Prime Minister Golda Meir reportedly said it was worth more than any diplomatic cable. The Galaxy's ability to deliver enormous quantities of war material directly to combat zones demonstrated strategic airlift's decisive importance. Desert Storm in 1991 showcased the C-5's capability on an unprecedented scale. Galaxies flew thousands of missions, moving entire armored divisions from the United States to Saudi Arabia. The air bridge the C-5 created allowed the U.S. to position overwhelming forces before Iraq could consolidate its position. One C-5 mission alone would deliver 2 M1 Abrams tanks with support equipment, cargo that would require dozens of C-130 flights. This capability allowed the fastest major military deployment in history. But the C-5's story isn't just military operations. In 1992, C-5s began humanitarian missions to Armenia, delivering over 2,000 tons of food and medical supplies over 19 days to a nation in crisis. The Galaxy airlifted relief supplies to war-torn Rwanda in 1994 and supported the British-led peacekeeping mission in Zimbabwe in 1979. After September 11, 2001, C-5s became the workhorses of the War on Terror, ferrying cargo into Afghanistan once suitable airfields were secured, then sustaining operations in Iraq and throughout the Middle East for 2 decades. More recently, the C-5M aircrew delivered 49,000 pounds of humanitarian aid to Guatemala City in September 2020, comprising 21 pallets of food, water, and school supplies. From disaster response to pandemic supply missions, the Galaxy continues demonstrating why strategic airlift matters. So what makes the C-5 irreplaceable? Why does the Air Force continue operating this 55-year-old design when newer aircraft exist? The answer lies in unique capabilities that no other aircraft in the world can match. First, let's talk about payload capacity. The C-5M can carry up to 264,440 pounds in its main cargo compartment. That's 120 metric tons. Additionally, it can transport 73 passengers or fully equipped combat troops in the upper rear passenger compartment, while simultaneously carrying maximum cargo below. The newest C-5M Super Galaxy can lift 2 M1 Abrams tanks, each weighing 70 tons, and transport nearly a company of troops anywhere in the world with aerial refueling. No other aircraft can match this combination of payload and range. The C-5 is distinct for having both front and rear cargo ramps, allowing much faster load and offload operations. This means vehicles can drive directly onto the aircraft from one end and off from the other end without backing up or turning around. The C-5 is distinct for having both front and rear cargo ramps, allowing much faster load and offload operations. This drive-through capability means vehicles can drive directly onto the aircraft from one end and off from the other without backing up or turning around. But it's not just about size. It's about versatility. The C-5 can carry outsized cargo that simply won't fit in any other aircraft, complete Apache helicopters, armored vehicles, satellite components, space station modules, or humanitarian supplies by the hundreds of pallets. In the airdrop arena, the Galaxy is capable of delivering up to 60,000 pounds of equipment by parachute, enabling supply operations to remote or inaccessible locations. The aircraft can perform low-altitude extraction deliveries where cargo is literally pulled out of the aircraft by parachutes while in flight. The C-5 has also supported the U.S. space program, transporting satellites, spacecraft components, and even space shuttle components between facilities. Its unique combination of volume and payload capacity makes it invaluable for moving large, delicate cargo that demands careful handling. The C-5 story hasn't been without challenges. From cost overruns during development to persistent maintenance issues, the Galaxy has faced criticism throughout its operational life. But understanding these challenges helps appreciate how far the aircraft has evolved. Earlier C-5As suffered from wing cracks caused by higher than anticipated stress. These structural issues grounded the fleet multiple times during the 1970s and led to comprehensive wing modifications. The re-wing program essentially replaced the entire wing structure on many aircraft, extending service life but at an enormous cost. Reliability was another persistent challenge. Early C-5s had notoriously low mission-capable rates, sometimes struggling to maintain even 60% readiness. Maintenance crews joked that the C-5 stood for "can't stay airborne for 5 minutes." Operating costs were astronomical compared to smaller airlifters. Each flight hour consumed vast quantities of fuel and required extensive maintenance. Critics argued the Air Force should replace the Galaxy with multiple smaller aircraft rather than continuing to operate these gas-guzzling giants. But the C-5M Super Galaxy modernization addressed many of these concerns. Modern engines dramatically improved fuel efficiency, advanced avionics reduced crew workload, and improved reliability. Structural upgrades extended service life. Today's C-5Ms achieve reliability rates exceeding 90%, numbers that would have seemed impossible 2 decades ago. The transformation proves that sometimes upgrading existing platforms makes more sense than developing entirely new aircraft. The C-5M delivers capabilities at a fraction of what developing and fielding a replacement would cost. As we approach 2025, the C-5M Super Galaxy remains as relevant as ever. The Air Force operates 52 Galaxies, with plans to keep them flying into the 2040s and eventually beyond. But what does the future hold for this legendary aircraft? Further upgrades are already on the cards, incorporating advanced weather radar, improved mission computing, enhanced communications, and next-generation air traffic management equipment. These continuous improvements ensure the Galaxy remains interoperable with modern airspace systems and operational requirements. The fundamental concept that made the C-5 successful remains valid today. Sometimes there is no substitute for size. While the C-17 Globemaster III handles most strategic airlift missions, certain cargo simply requires the Galaxy's unique dimensions and lift capacity. Looking ahead, The Air Force is studying potential C-5 replacements under various programs, but no aircraft currently in development can match the Galaxy's payload capacity and volume. Any replacement would likely cost hundreds of billions of dollars and take decades to field. The C-5's legacy extends beyond its operational achievements. It demonstrated that strategic airlift is a decisive capability in modern warfare and humanitarian operations. It proved that continuous modernization can extend aircraft service life far beyond original expectations, and it showed that sometimes the biggest challenges require the biggest solutions. The Lockheed C-5 Galaxy has earned the title as legendary. For 55 years, it has been bigger, heavier, and more capable than any competitor. From saving nations in crisis to supporting military operations worldwide, the Galaxy has proven that strategic airlift is more than moving cargo. It's projecting American power and values globally. With departure reliability exceeding 90%, payload increases of 20% over legacy variants, and substantial improvements in range and efficiency, the C-5M Super Galaxy is delivering more to the warfighter and humanitarian missions than ever before. If this deep dive into the legendary C-5 Galaxy impressed you, hit that like button and subscribe to Project Aerospace for more in-depth coverage of aviation's most iconic aircraft. What aircraft should we feature next? Let me know in the comments. Until next time, remember, when the world needs massive quantities delivered to impossible places, there's only one aircraft that can answer the call. The C-5 Galaxy remains unstoppable. This is Christopher Wales for Project Aerospace signing off.